Well, I'm going to keep making videos, and we're going to try and keep learning, because if there's like a hint of a dark cloud in the sky, I think we're going to cancel school again. So we're just going to try and keep going here. We've talked about solving by graphing, substitution, and elimination. And substitution and elimination we have to cover through videos, which I'll also let you find and repost. So I want to talk about elimination and substitution again. Elimination is the one where you try to cancel out a variable. So look at this first equation here, and maybe pause the video or think to yourself, what could you multiply the equation or equations, top, bottom, or both, by to get one of the variables to cancel? And there's actually a lot of options. I'm going to multiply the top equation by 2. I have to do it to both sides, and the bottom equation by -3. That gets me a 6x and a -6x, and those will eliminate each other when I add up the two equations. So 6x minus 10y equals 20, and -6x minus 6y equals -36. When I add up these two equations, I get -16y equals -16. Divide both sides by -16, and y equals +1. Now that I know that y equals +1, I take that and plug it into one of my equations for y. It doesn't matter which equation you pick. So 2x plus 2y, but y is now -1, equals 12. So 2x minus 2 equals 12. So 2x equals 14, and x equals 7. This is the point 7, 1. I'm going to check that because I feel like that's off. If I plug in 7 for x, I get 21 minus 5, which is not 10, and 14 plus 2 is not 12. Minus, so where's this off? This is a positive one, which means that this should be a +2, which is going to make this a 10, which is going to make this a 5. 15 minus 5 is 10, 10 plus 2 is 12, yes, this checks. That's why you check your work, because you might make a mistake, so go back and see if it works in both of them. What I did is I just took my values of x, which were 7 and 1, and I plugged in 7 and 1 for x and y, and it didn't work in either equation. So then I figured I made a mistake somewhere, I had to go back and retrace my steps, I found it, and I fixed it. Okay, look at the second equation. Pause and ask yourself, what could you multiply the equations by to get things to cancel? And as I've said before, you can always take this number here and put it up here, positive or negative, and this number here and put it down on the bottom. So I'm going to multiply the top by 7 and the bottom by -6. That gets me a -42 and a +42. (42x plus 66y equals -6. Now I add these up, and I'm going to get -14 plus 66 is 52. So 52y equals -104. Divide both sides by 52, and y equals -2. Take that and plug it into one of my equations. I'll go into this one here. So -6x minus 2 times -2 equals -14. So this becomes a +4, -6x plus 4 equals -14. This is going to become x equals -3. Because we get -6x equals -18. So x equals +3. It's the point 3, -2. I'll check that. -18 plus 4 is -14. -21 plus 22 is +1, so that works. That was solving by elimination, where you eliminate variables. It works every single time. You can always do it that way. Substitution is nice only if, so down here on the bottom I'm doing substitution. Substitution is nice only if you can get a variable by itself without making any fractions. So here, this -2 can go into 6 and can go into 12. That's the only number out of all 4 of these options, the only number that goes into the other 2 numbers in its equation. So I'm going to get that y on top by itself. So I have 6x minus 2y equals 12. I'm going to subtract 6x from both sides. -2y equals -6x plus 12. Divide everything by -2. and we get y equals 3x minus 6. Now that I know what y is equal to, I take it and I plug it in to the other y. So I'm going to put it in right here. So I get 3x minus 4 times 3x minus 6 equals negative 3. 3x minus 12x plus 24 equals 3. This is a negative 3, excuse me. I distributed the negative 4 to do that step. Combine my like terms, I get negative 9x, subtract 24 from both sides, equals negative 27. So x equals 3. Divided both sides by 9x equals 3. Plug that into this box up here. If x equals 3, and y also equals 3. The solution is a 0.33. I can check that. 18 minus 6 is 12. 9 minus 12 is negative 3. I plugged into both equations and it works, so it checks. That's the basics of solving by elimination and substitution. Those are the two methods you'll use the most often because graphing can be imprecise and can be cumbersome and isn't always very useful. Sometimes it's very useful, but most of the times you'll use substitution or elimination. Where you use them is on word problems. Now, these are the steps that I follow when I'm solving word problems. I would like you to try and mimic them as you do them also. First, read the problem and know what it's asking you to do. You have to actually understand the problem. If you can't understand the problem, you're in real trouble. So I'm going to read the problem. It says, you look into a barn full of pigs and ducks. You see that there are 25 heads and 72 feet. How many pigs and how many ducks are in the barn? Now, first of all, this is a very stupid problem. You know, it's a problem where we're counting feet and heads as opposed to just counting pigs and ducks. It's a problem where pigs and ducks are for some reason in a barn together. If you can count 72 feet of animals that are walking around in a barn, you can probably see the animal's foot and be like, oh, that's a pig's foot, or that's a duck's foot. But instead we've made it this kind of stupid problem that you would never have to actually do. Stupid problems are nice, though, because they can be simple, and because they can explain or set up ways to solve other problems. So I've read the problem. I know I'm trying to find how many pigs there are and how many ducks there are. And that is my variables. Now, x can't just be pigs. It has to be something I can represent numerically, like number of pigs. And y can't just be ducks. It has to be number of ducks. Variables have to be things that can be numbers, like number of pigs, weight of pigs, age of pigs. Things we can represent numerically. Color of pigs, I probably couldn't use as a variable without getting real sneaky. There's my variables x and y. Those are the two things I'm trying to find. Next, I use the info from the problem to set up equations. Well, I know there's 25 heads, and we're going to assume that none of these pigs and ducks are mutants. They all have one head. So if you can, pause the video, try to set up the equations first. One of the equations is x plus y equals 25, because the number of pigs, that's what x stands for, the number of pigs plus the number of ducks has to equal the total number of heads. Number plus number equals number. The other equation, there's 4 feet per pig and 2 feet per duck, and altogether there was 72 feet. This is number of feet total for pigs, total number of duck feet, and total number of feet. Pig feet plus duck feet equals total feet. The units have to match up when you make your equations. This one here was basically heads plus heads equals heads. I can write that. Heads plus heads equals heads. You get the idea. And this one is basically feet plus feet equals feet, which makes sense. If you take feet and add them up, you're going to get more feet. Had I tried to add feet and heads, like had I done 1 duck head plus 2 duck feet, I can't add that. Like 1 duck head plus 2 duck feet doesn't equal 3 somethings. They have to be like terms. They have to have the same unit on them. Now I have a system of equations. This can solve by substitution or elimination. They're both going to be pretty easy. I think this one substitutes really well. I'll get the x on top by itself. I subtracted a y from both sides. I'll now take this, plug it in here. I have 4 times 25 minus y plus 2y equals 72, which means that 100 minus 4y plus 2y equals 72. Subtract the 100 from both sides. Negative 2y equals negative 28, so y equals 14. If y equals 14, then x equals 11, because there's 25 total things. So there were 11 pigs and 14 ducks. I'm going to see if that makes sense. 11 plus 14 is 25, and 44 plus 28 is 72. The answer makes sense. It checks. Everything is good. 11 pigs, 14 ducks. Okay, here's a less stupid problem, but still kind of a silly one. But this is a problem that people might actually have to do at some point. At the last basketball game, you were working at the mayor's booth selling t-shirts and sweatshirts. T-shirts sell for $8 and sweatshirts for $15. Altogether, you sold $93 worth of stuff, and a total of 9 items. How many shirts and how many sweatshirts did you sell? The thing that's stupid about this problem is ideally you would have receipts. You would know how much stuff you sold and wouldn't have to ask. But maybe you lost something, or maybe it got misplaced, or maybe you want to double check and make sure. Problems like this have to get done every once in a while. Well, what am I trying to find? See if you can define the variables on your own. X will stand for number of shirts, t-shirts, Y will stand for number of sweatshirts. So here's what we know. We sold $93 worth of stuff, and it's $8 per t-shirt and $15 per sweatshirt. So I'm going to do $8 per t-shirt, $15 per sweatshirt, and altogether that's $93. We also only sold 9 items, which means that X plus Y has to equal 9. Number of things sold altogether is 9. Now, a lot of you will look at a problem like this and think, I can just guess and check this. I mean, if I'm only selling 9 things, I can try 9 and 0, 8 and 1, 7 and 2, 6 and 3. And yeah, this problem can be guessed and checked, and it wouldn't take too long, but it's easy to get problems that would take an incredible amount of time and energy to guess and check. They can be done still with this process rather simply, so work to understand this process. I can again solve this by substitution, but this time I'll do elimination just to change it up. I'm going to multiply the top and the bottom by -8. So I'm going to have 8x plus 15y equals 93 from the top, and -8x minus 8y equals -72 from the bottom. I add these up, and I get 7y equals 21, which means that y equals 3. We sold 3 sweatshirts, so we sold 6 t-shirts. Those numbers check out, because 24 plus 90 is... Not 90. Oh, I have it backwards. 48 plus 45 is 93. So this one checks. And 6 plus 3 is 9, so this one checks. We sold 6 t-shirts, 3 sweatshirts. Not so bad. Here's a problem that's worth doing. It says Verizon offers a cell phone plan that costs $30 per month plus 10 cents for every gig of data used. AT&T offers a cell phone plan that costs $40 per month plus 6 cents for every gig of data used. After how many gigs of data is Verizon more expensive than AT&T? Now these numbers are made up, but this is essentially a process you can follow to determine which cell phone plan is going to be best for you. Verizon is costing less per month as a flat fee, but charges more to use data. AT&T costs more per month, but charges less to use data. So if you're going to use a ton of data, you probably want to use Verizon. If you're not going to use very much data, you probably want to use AT&T. But we can figure out how much data is a ton of data or is not very much data, how much data makes one plan cheaper than the other. This is a problem that actually solve it by graphing works out really nicely because you can see very clearly how much each plan costs at a certain number of gigs. But first we're going to start with defining our variables. See if you can define the variables and set up the equations before I do. Again, remember you can pause. X is going to stand for number of gigs used. Y is going to stand for the total cost. And this equation doesn't set up like the previous ones because it's got 2 different scenarios. It's got a Verizon scenario and it has an AT&T scenario. Verizon, the total cost, Y, the total cost is going to be 10 cents per gig plus a flat fee of 30. AT&T, the total cost is going to be 6 cents per gig plus a flat fee of 40. So those are my 2 scenarios. Now what I want to do is find out, when do these two cost the same? When do they have the same cost? Because when they have the same cost, then I'll know how many gigs makes them come out to the same price. If I'm going to use more than that gigs, I'll pick AT&T. If I'm going to use fewer number of gigs, I'll pick Verizon. But I want to see when they cost the same, which means I'm going to substitute. I'm going to take this, since y equals this, I'm going to plug it in for the other y. I get 0.06x plus 40 equals 0.10x plus 30. I forgot to put the x on this. And then we'll solve this for x. So I'm going to subtract 0.06 from both sides, and subtract 30 from both sides, and I get 10 equals 0.4x. If we analyze this for a second, these numbers, they don't actually just come out of nowhere. This 10 represents how much more expensive it is to start with AT&T compared to Verizon. And this 0.4, that should be 0.04, excuse me, not 0.4, 0.04. 0.04 represents the 4 cents per gig more expensive that Verizon is than AT&T. So basically the question becomes, how many times do we have to use our 4 cents per gig extra to make up the 10 missing dollars? Like, how many gigs will make up the $10 if it costs 4 cents per gig? So we divide both sides by 0.04. 10 divided by 0.04. I'm going to move this decimal 2 to the right, move this decimal 2 to the right. So I'm doing 4 into 1,000, which is 250, but we'll just work it out. It would take 250 gigs, which, oh my gosh, is a lot of gigs. So basically, if you're going to be doing these plans, unless you're going to use an insane amount of gigs, you're going to want to be using the Verizon plan every time, because it's going to be cheaper. I'm going to leave these problems alone. We'll talk about them later. I just want to leave us with this now. There's basically two types of word problem setups. One is where you have slope-intercept form twice. This was our AT&T Verizon problem. You have two scenarios, and most importantly, they have an independent and dependent variable. Whenever you have an independent and dependent variable, you're going to be using slope-intercept form, which is y equals mx plus b. This is like if we have distance equals rate times time problems, cost over time problems, anything that has a rate is going to use slope-intercept form because that has a rate, it has a slope. The other problem I call side-by-side, which has standard form, ax plus by equals c, or dx plus ey equals f. This is whenever there's things being combined or mixed, or if there's not a rate, if there's not an independent variable present. So like when we mixed up the chickens and ducks in the barn, or when we mixed up the clothes in the Marist shopping center, or whatever that problem was, that store. Whenever things are being thrown together or mixed together, whenever there's not an independent or dependent variable, you're going to use this form. Oftentimes, it looks like this, where this is like number of heads, total heads. And this was like feet per pig, feet per duck, total feet. It often has x plus y equals something, and then a multiplier on x, a multiplier on y, and a multiplier on the something. Not always, but often. I know this was a long video. We'll talk about it more in class, but I thank you for dealing with it, and I will see you next time.